Alright, here I want to show you how you can draw the left end elevation of this building whose plan is given. Though, as I've said in the first video, which was on the about the plan that we have done, I said that I will be working on the plan that has been done, the front elevation that has been done, and I will also work on the left end elevation in case you are asked to draw the left end elevation of a building like this. So I want to show you how it's going to look and how you can construct it. So then after this particular video, I'll be working on the sectional view. So look forward to that. Now, before I move on for the work, if you have not subscribed to this YouTube channel, you need to subscribe if you are actually a technical drawing student. So you need to subscribe so that whenever I upload a new video, you will be notified. That is when you activate the notification bell. And then if you have friends who are technical drawing students, try as much as possible to share this video with them and tell them about this particular YouTube channel on technical drawing. It's a place where you can learn everything that has to do with technical drawing in a raw form. So you see how I undo the compass, the ruler, the T-square, the set squares, and also the French curves. So it's very, very important that you come to this channel and learn and learn. So, and then don't forget to practice. You cannot be watching this video without practicing. It is when you practice that you can master it and know it better than I do. Now let's go to the work. Now, I want to draw the left end elevation. This is the right side of the building and this is the left side of the building. So we want to draw, we are standing around here and we are looking at the building around this particular part. So we want to draw the left end elevation, that whatever we see here is what we want to draw. So whenever you are asked to draw the left end elevation according to orthographic projection is found on the right side of the front elevation So now you don't have to worry yourself about that because I'm only putting it on this part of the paper. So what do we have to make use of here? So we are using all these dimensions. So I've done the calculation, and by my calculation, the total length here, so you just need to work with the dimensions. So the total length here is 10,785 if you add the thickness of the walls together as we have here. So if you add them together, you are going to have 10,785 as the total length from here to here. And don't forget that you are making use of a scale of 1:100 as stated, that we should draw the front elevation, likewise the end elevation. We are going to use a scale of 1:100 to draw it. So we are going to divide every dimension by 100. And as I've done that by dividing 10,785 by 100, that gives me 107.85. So which I can approximate to 108, and I'm going to use 108. So the first thing that we need to do is to draw the ground level line. So you draw a line like this as your ground level line. Then the next thing that you are going to do is to take your set square. So take your set square, draw a vertical line like this. So draw a vertical line. So draw a vertical line here. So from this point on the vertical line, so take a measurement of 108. A measurement of 108. So looking at this, so this is 70, 80, 90. So this is 100 and I'm taking 108. So this is 108. Okay. So with this, I will also draw a vertical line at this point. I will draw a vertical line at this point. All right, so the next thing that I'm going to do is that, don't forget that this is my ground level. So we indicate the ground level with GL. All right, so that's my ground level. That's the ground level. So the next thing I'm going to do here is that, because when I'm looking at this building in this direction, I'm going to see this window on the wall. I will see this window on the wall. I will see these two windows on the wall. So those are the things that I'm going to see, so which I'm going to put on the wall. But before we do that, let's work on the roof first. Let's work on the roof. So when we are done with the roof, you come back to that of the windows. So the first thing that I'm going to do here is that, for us to draw the roof, so we are going to make use of the dimension of floor to ceiling height. The dimension for floor to ceiling height, which is given to us here as 3,000. So this 3,000, we are going to divide it by 100, and that will give us 30. So you have to take a measurement of 30 millimeters. A measurement of 30 millimeters. So from here, so this is 30 millimeters. Then here you draw your horizontal line. So this horizontal line that I'm drawing is a thin continuous line. When I use my red pen to draw, I'm using that for a thin continuous line. So when I use a black pen, I'm using that for a thick continuous line. All right, now, so the next thing that we are going to do is that you take your protractor. So when you take your protractor, I need to explain something to you, that when you are looking at this building in this direction, on this end, this is the shape. You are going to see the shape here. It will look like a triangle, or it will be a triangle as we have it, because we are looking at it from this end. So this is the shape that we have on the end. This is the shape that we have on the end. So as I've said, the shape on the end elevation is of the roof. The shape of the roof on the end elevation is a triangle, to look like a triangle. So what you just need to do is that we are given a pitch angle in our roof. Don't forget that in the specification for the roof, we are given a pitch angle 15 degrees. So what you need to do is to take your protractor, so you set it at this point, at the point of intersection of this vertical line and this horizontal line. So you set it here, and you come to this side, to the left side. So you take a measurement of 15 degrees. So this is 15 degrees, and then so you bring it to this side. So you also take 15 degrees. So this is 15 degrees. All right, so the next thing that you need to do is that from this point, so from this point here, so you draw a line through that point for angle 15 degrees, and from this point also, so you draw a line through the point. All right, so we have this. All right, the next thing that you need to do is that from this point, just come down a little bit, like 5 millimeters, like 5 millimeters, like 5 millimeters. So you move your T-square to this point, and you draw a horizontal line to the left, and draw a horizontal line to the right, like this. Then each projection given to us for the roof, they said if each projection is 600 millimeters, 600 by 100 will give us 6. So each projection is the distance of the end of the ceiling from the wall. So you take a measurement of 6 millimeters. So from here, 6 millimeters, and you come here, you do the same. Take 6 millimeters to the right. Okay, then so you draw this up as a vertical line like this. Let it touch this line. So you come here also, you also do the same. So let it touch this line. All right, so the next thing that we are going to do is that we are going to have fascia board. We are going to have fascia board. So this line is going to serve as our fascia board. So what I'm going to do is this. So come to this point, to the point of intersection of the lines, and draw a short vertical line like this. All right, then on this line, so I will need to make use of my protractor, So you set it like this, set at this point, and you want to draw a perpendicular line to this line. So you want a perpendicular line to this line. So, and then you bring it to this point. That is this point here. We are making use of this point. So you bring it to this point. So you set the protractor on this point and you take note of that 90. So I will just set my ruler like this and just take a short distance. Okay, so here also I will set it like this and just take a short distance. That's what I need. So the next thing I'm going to do is that, so for the fascia board given to us, the dimension for the fascia board is that we have 250 by 25. This 250 is the wideness of the fascia board, while 25 is the thickness of the fascia board. So just come here, divide 250 by 100. That will give us 2.5. 2.5 can be approximated to 3. So approximate to 3 millimeters. So this is 3 millimeters here. This is 3 millimeters. And then you come here. So on this line, you also take 3 millimeters. So this is 3 millimeters. Okay. Then on this one, so here you take 3 millimeters. So this is 3 millimeters. Okay. Then, so from here, so you draw this line from here to here, and then from this point, so you draw this line from here to here. All right, so that line is for the fascia board. So the next thing that we are going to do is to put the roofing sheet. So how do we do that? So what you just need to do is that we are not given a dimension for that. So what you just need to do is that just come up a little bit here. So take like 2 millimeters. Take 2 millimeters from here. So this is 2 millimeters because the roofing sheet has a thickness. So these 2 millimeters that we are taking is for the thickness of the roofing sheet. So so you take this. So you also take 2 millimeters here. So take 2 millimeters. So you need to extend this line a little bit. So extend this line a bit, and you also extend this line a little bit. Oh, rí mélòó ni? Bá mi count gbogbo script yẹn. Bá mi count gbogbo ẹ̀. Ó yẹ kó jẹ́ 65 ẹ̀ kó jẹ́. All right, so the next thing is, so just take, because the ribbon sheet will go a little bit beyond the ceiling. So what you just need to do, just take like 3 millimeters from this point to this side, 3 millimeters, and you also come to this side, you take 3 millimeters. So take 3 millimeters from here to here. All right, so okay, so from here, so draw this line, and from here, so draw this line. All right, so the next thing that we are going to do is that, so these 3 millimeters that I have here, I'll just join it, and here I will also join. Okay, I think you are not able to see this very well, so I will bring out the shape now. I'll bring out the shape so that we can see it. Okay, so for the fascia board, all right, so the shape is coming out, so you're able to see it now. You're able to see it now. All right, so I will also make this a thick line. I will also make this a thick line. Then make this a thick line. Make this a thick line. All right, so then this will also be, is also a thick line. Then I made this a thick line. So this is a thick line, and this is also a thick line. All right, so we are not done with the roof yet. We are not done with the roof. So there's something I need to put up here. That is the ridge. That's the ridge cap. That's the ridge cap. So I have to show the end of the ridge cap around here. So that's what I'm going to do now. So what we need to do is that, so we come here and take a measurement. Just let's take like 2 millimeters. 2 millimeters. So I will like this, and also just try as much as possible to make it equal. So draw to this side, then take a measurement of like 7 millimeters. 7 millimeters. So here also take 7 millimeters. 7 millimeters. Then so draw this line. So draw this line. All right, so the next thing I'm going to do is to make it feasible. All right, so that's the ridge cap. So that's the end of the ridge cap on the roof. So now the next thing that we are going to do is to put the windows on this wall. That's the next thing that we want to do. Now, all right, so to put this window, I've done my calculation from year to year is 35, and from year to year is 14, and from year to year is 44. So what I'll just do is that, so I'll come here and take a measurement of 35 millimeters. This is 35. Then the next is from here, I will take 14 millimeters. I want to rightly position the windows. That's the purpose of doing this. So I will take 14 millimeters. Then the next is 44 millimeters. 44 millimeters. So this is 44 millimeters here. Okay, so I want to rightly position the windows. I don't want to put the windows anywhere. So I want to rightly position the windows. That's the purpose of doing this. So I just take this line up a bit. So take this line up, and this line I will take it up a little bit. So now the next thing I'm going to do is that, so the window, this window is around here, this window is here. So what I will do is that, so I'll just go up a little bit. So that is W1, and the specification, so we have that the dimensions for W1 is 1100 by 900 by 25. So this 1100 is the height, 900 is the width, and 25 is the thickness. So we are making use of, on this end elevation, we are making use of 1100 and 900. That's what we are using here. So what I will just do is that I will go up a little bit here. Okay, so I will draw, and so I need to draw it on this side too. Okay, so the next thing I'm going to do is that, so with my set square, so I will put it in the middle. So I will try as much as possible to put the window in the middle of the wall. So draw a line. So then you take a measurement of 9 millimeters. 900 by 100 is 9. So you take a measurement of 9 millimeters from here. Okay. Okay. So I will take 1 millimeter first. 1 millimeter first for the 1 millimeter for the frame. Then I will take 9 and then take 1 to this side. All right. So next thing I'm going to do is that, so I will draw a vertical line here. So draw a vertical line here, and here also a vertical line. So then I will take 1 millimeter up here for the frame, and then I will take 11 millimeter down. So 110 and 1100 by 100 will give us 11. So this is 11. Then I will take 1 millimeter down. All right. Okay, so next thing I'm going to do is to make the window more visible. Alright, so I've drawn one, but I've not completed it because we are told that all windows are glazed aluminum sliding type with frame. So I want to show that this is a glass. We have glass here. We have a glass here. So that's what I want to show here. So I'll show as I did that in the front elevation. So that's the symbol to show that it's a glass window. And then, so it's a sliding window. It's a sliding window. So okay, so I'm going to draw a line like this. Now I put arrow on it. Put an arrow on it so that to show that it can slide. Okay, so this is to show that we can slide it. Alright, so I'm going to do the rest of the windows, then I will come back after I'm done. Alright, I've put the windows, but there's something that I need to clarify here, because in the front elevation that I did, there is a little mistake. What is that mistake? So I need to tell you. I don't want to hide anything from you, and I can't hide anything from you. Now, look at these windows. I didn't put into consideration what we are told about the windows in the specification, that all windows are glazed aluminum sliding type with frame. So I didn't put that into consideration in that front elevation. So yeah, I just remembered this now. So I made use of these dimensions. That's correct. So now, because they are sliding windows, they will be in two pieces. They'll be in two pieces. Like this one now, as shown in they showed us in the plan that this is a single window, but when you are putting it in the front elevation, it will not be a single window. So it will be, it's a single window, but it's in two pieces form. It's a single window, but it's in two pieces form. So that's why I put a line to separate them, that we have one here, we have one here. So each of them can slide to the left and can slide to the right. The same thing applies to this, the same thing applies to this. So take note of that. Now, when you are done like this, so you need to write left side elevation, and then you write the scale. So having done this, the work has been completed. I've shown you how you can draw the left side elevation of a given building plan, or of a given building. So it's as simple as I've done it here. All you need to do is to practice, and don't forget to subscribe to my YouTube channel, and remember to put on the notification bell so that whenever I upload a new video, you'll be notified. And also share these videos with your friends. Tell them about this YouTube channel, and keep on practicing. Thank you for listening. God bless you.